Okay, hi everybody. My name is Nader. I'm going to talk to you about testing strategies for pipelines. First, a little bit about myself. My name is Nader Ziada. I work for staff software engineer at VMware. I've worked on a bunch of CI/CD projects previously, Tecton when it was first starting, and Conquer CI, which was probably not as famous. Most of you probably don't know it by now. Also, recently, I've been working on a lot of Kubernetes stuff, Cluster API, Knative, and currently working on supply chains for VMware. Today, we're going to talk about the importance of testing your pipeline, kind of how to approach it, how to effectively test it, and key areas of testing it to make sure it's a successful pipeline. Okay, so we have this new project. We're building a new app. It's like a Twitter, Blue Sky, whatever, some kind of app we're building. You're posting stuff, has a timeline, and have a database, and like a normal standard app, your new project. So as a good project team, we're building our cool new pipeline to make sure everything works fine and is automated. We get our code, we build it, we test it, we run our tests, everything is good, and then we deploy it to our production environment. The app is running, users are happy, and everything is good. And then as we go along in the project, we start, of course, to add new features and add new things, and we're updating our pipeline. So we go and add this configuration step for our deployments. We have our new environments, we have testing and staging, and a bunch of other environments that we need to update. And we go and make some changes to our pipeline, and now we're updating, so our app is updated. I think something went wrong with the app, but we don't even notice that. Oh, and then later we realized something was configured wrong in our configuration step in our pipeline, and parts of the deployment went in the wrong environment, and now some of the users' timelines are kind of messed up, and the app is not working. And we didn't notice it until it was actually in production, because the pipeline had a mistake in it, and we didn't know. That's one example of things that can go wrong in your pipeline. Another example, this actually happened to me also in a previous project. We had this like really good upgrade testing pipeline, testing all the different combinations. We're releasing a new product. And then after our release, we hear back from the customers, like the upgrade is broken, it's not working. And then later we realized after investigating that we missed one of the different combinations of the upgrades and was never even tested. And then we had like to create a patch, and like there was a problem and a big mess for no reason. It's just that we missed it in the pipeline. So obviously you see that even though we don't pay much attention to testing that the pipeline is doing what the pipeline is supposed to do, we just assume we're going to test our code is good, and then we're going to use the pipeline to automate our stuff and deploy it and send it to customers. It can be causing a lot of problems that we're not even aware of. So maybe we should write tests for it, same as we do for our code. So really, the pipeline is mostly just like a bunch of steps. Each step is executing some kind of code, script, or something like that. The two approaches that I've seen or done in my experience in previous projects are one of these two approaches. The first approach, and we're going to talk about both of them. The first approach is to treat like your each step, consider if it's getting like a bash script. We're going to get into each one of them in details. If it's like a script, mostly done in bash and is getting too out of hand, maybe you can change that into a language that you can write tests for. For example, I'm going to use Golang as an example, but you can use whatever language that has a testing library in it, and then have actual unit tests to ensure that this step is actually doing what it's supposed to be doing. That's one approach. The other approach is to have like a framework to actually like deploy your step and test it and make sure it's actually executing what it's supposed to be doing. If we go with the first approach first, so you're going to use a language that actually has a testing framework. I've used Go before. If something was getting too complicated, like a bash script was getting too long, or is dealing with a lot of different steps, different if conditions, and different situations it has to deal with, then maybe it was good for us. It was good to use Golang and replace our bash scripts. The only kind of overhead is that you have to like kind of compile it every time and then put it in your probably container image that's going to be run in the step. So this might be something just to keep in mind. If it's something that's like you're changing so frequently, it might not be a good candidate for it. So for example, you have here, this might be too small, but like for example, you have like in your script, you have like the first section, you're checking a bunch of dependencies. You can replace that by like a Go code that's checking all these dependencies and just like replace this one line. And this is like, you know, it's tested. You have unit tests for it, you know that it's solid. And then this way, it's kind of, you feel comfortable with that. And then this is like the one line in the script that is not going to cause problem. This is like an area that have caused problems for us before. Or something else, like one of these different sections that you're doing something complicated, you can just like be calling a Go script. If you go like extreme case, you can do everything in Go, for example, or Python or whatever language, and just like have the one line in your Tecton task, just calling that, and then everything is tested, and you're more comfortable with it doing what it's supposed to be doing. What are some things that are good candidates for being used in like a Go program or whatever language? Like network stuff, like we've had parts of our top pipelines that had to interact with like an API. I don't know if any of you were here before. In the previous presentation, they were giving an example. In this room, they were giving an example about their Docker file that was Go pulling some script from like their partner, and then pulling it down, and then executing in the Docker file to build their image, and then like the partner kind of, or the vendor replaced that file and replaced the script, and it wasn't there anymore, and their build was broken. So dealing with something like that in Go language and having testing for it, or having like checks and validations and stuff like that will make it easier to catch these kind of things. Or also other candidates are processing large amounts of data, or like parsing log files, or looking for specific patterns. I know the Kubernetes project built this whole release tool in Go, and they use that in their stuff. To make it easier, they pull like the release notes from the different commits and do stuff like that. I think it would be a lot easier in a language like that and being tested than doing it in Bash. The other approach that we ended up also using in other projects was having a framework. I haven't really seen existing frameworks that are very flexible and can cover or are like generic enough. So in our case, in the project I'm working on now, we have our own small framework, and I'm going to talk a little bit about what it does. But this gives you the flexibility to like have more coverage of your steps and tasks. Gives you room to add more to it easily as your pipeline evolves. And in our case, we're doing Kubernetes resources that gets deployed in a cluster. So we needed a way to be able to validate these, like our CRDs are deployed our resources and check the status of specific things in them. So we had to build our own kind of matchers to match for that. So it's easier for us to build that. We couldn't find anything that was like that we could use. In our case, the framework was basically doing like these steps. So it's creating a cluster, which is like easy for you to do using like a kind cluster or something like that. As deploying our code, which is like the controllers that we're trying to test. Like these are the controllers that we've changed. And then applying the test, which is like the resource. Like for example, we apply this workload resource, and then see it, like the point is to apply the workload resource, and then it will work on the changes that you've done in the controller, and then see the output resource, how it updated it or reconciled it. And then you validate the status of the resources that got created, what the status happened, like does it meet what you were expecting or not? And if something goes wrong, of course, you go and check the messages, you can log whatever you need to log, and have specific conditions. We had assertions for like each one of the different status values, like to make sure that this ingress got resource got created with like label equals whatever, and things like that. And then each one of them is in a thread, so it's very easy and quick to kind of catch what went wrong and be able to fix it. And then, of course, you can have like the cleaning up of the environment after you're done with running your test, so that the next test can go on a clean environment and so on. We run this on, you can run it locally, you can run it from, we can run it locally on a Kind cluster, you can run it on your CI, but it really helps when you're making changes to make sure that your actually pipeline is actually, we're kind of treating it the pipeline. We always hear that like we should treat your infrastructure as code, and make sure that your infrastructure is like checked in and everything in your pipeline and so on, but not a lot of people actually test it and make sure it's doing what it's supposed to do. So of course, everything is working separately, but you also have to have some kind of integration test. Like we have end-to-end tests that are just like, we had a problem before, like the deploy example that I talked about at the beginning, where one step was working, the next step was working, but one of the data was not being passed between them properly, so that caused a problem. So if you don't have like an actual whole pipeline being tested in your test environment, then you might not catch things like that. So testing each step by itself, plus testing the whole end-to-end is also very useful. So of course, not everybody has the capacity or to write all these tests or make changes to their, like sometimes people don't even have the capacity to test their own code, and let alone to test their pipelines that are just deploying the code. So we're going to talk a little bit about what parts are more critical to test. So these are like the criteria that we go by, like the risk of failure, which task has like a higher chance of failing, causing a bigger problem. The cost of failure, which task would, if it failed, has a higher impact, and which task, if it works well, will have a higher reward or benefit. This is pretty like a good criteria that we went by to kind of figure out our priorities in which ones to start with testing. So if we go through this pipeline and kind of think about it, these criteria, the get code is pretty basic. It's just pulling the code down. If it fails, you'll obviously know right away. It's probably easy to catch, so you don't have to worry too much about testing it too much. You can like test it, but it's not like a high priority. It's like a low impact one. So is the build. Like if your build is failing, you'll catch that pretty quickly. You don't have to worry about it too much. So I would say like the first two are probably lower priority to be tested. The test one is like a little bit more medium, just to make sure you're running the right tests, to make sure you are running the right test against the right environments. If there are multiple environments, so maybe like a medium priority being tested. If it's not tested, it could lead to some problems that your code is not being tested and things are being missed and stuff like that. Because mostly when we have all these infrastructures of pipelines in place, we rely on it. If everything is green, we kind of don't notice too much if some of the things fell through the cracks and doesn't happen. So test is a little bit medium. You need to kind of make sure it's running against the right stuff. Deploy, I would say, is the most critical one, because if you're, for example, in our case, we were deploying to production based on a bunch of different testing steps. If that is doing something wrong, we didn't have any this was like a small project, so we didn't have any like blue, green, or like canary, so we were just like testing to production. So this is like a higher impact to be tested. The impact of this one going wrong, I would say is pretty high. So just kind of recap this part. Like the deploy has a higher risk of failure because deploy is just dealing with the different environments, different configurations, everything has to go right. The cost of failure of it is bigger, and the value of success of it is high because end user is using the app. Otherwise, the end user is not able to use the app. The test is medium because cost of failure is high because your app has something wrong with it. It's not working. But then the value of success is high. Your application is more solid, but the risk of it is a little bit less. The get code and the build, I would say, is low because risk of failure and cost of failure are pretty low. So just to recap quickly, we need to find a way to test each task of our pipeline. The complicated parts of bash scripts or scripting would be useful to use in a language with a testing framework. In my experience, we've used Go. It was useful because you can easily compile it and put it in your container image. But any language that you're using in your project, you can use, that's fine. Or use or build. If you have a framework that you can use or you can build your own to test your tasks, that you can just deploy it. In our case, because it was a Kubernetes resources, it was kind of easy to just build this small framework that is, most of the work in that framework was really in the matchers, like the checking of the different status of the resources. But like the deploying of things is pretty straightforward. End-to-end tests are super important to make sure the interactions between the different steps and the tasks are working as expected. Start with the more critical tasks in the pipeline that like we've talked about. And we've talked about how kind of to try to figure out which ones are more important. I guess the message is the pipeline should be a tool to make your project more efficient and working much better. Automating your stuff, it should not be a source of problems for you. So just by having this, investing a little bit in just making sure that your pipeline is doing what it's supposed to be doing, and ideally have some kind of periodic, like nightly job or something that, or whatever duration, but just some periodic job that goes and runs that and tests it and makes sure that your pipeline is kind of continuously working as you think it should be working. That will save you a lot of debugging and issues that you can run into if your pipeline has issues and you don't realize it. Does anybody have any questions? I think it went a little bit short, but good news is it's about to be lunchtime, so at least you have. Yeah, please go ahead. I think, hold on, let me give you that. Sorry, thank you.
I just want to ask, so do you also run end-to-end tests in your sensitive pipelines?
Sorry. I think.
Yeah, the question is, do you run end-to-end tests in CI/CD?
Yeah, we also run end-to-end tests to make sure that the pipeline, you mean like run end-to-end tests about testing the pipeline itself?
No,
not the same pipeline. Yeah, the pipeline, these tests we're talking about are testing the actual pipeline itself. And then we have also end-to-end tests that are like executing our code, yeah.
Okay, but they run separately outside of CI/CD. Okay,
yes.
Makes sense, thanks.
Sorry, Peter, there's a question on the other side.
No worries. So I'm assuming that we run that test every time that you make changes to the pipeline. Do you also try to run these tests in other situations, like maybe eventually when like frequently?
So in our case, we have a periodic job that runs these tests in case things that change, like external dependencies, you're pulling down stuff, you're building images, stuff like that. So we have a periodic, I think it's nightly, and you just like have it in the background and it's running and you don't have to worry about it. And then sometimes it catches stuff. But yeah, we do have a periodic test for these.
Okay, sounds good. So you run these 2 times. Okay.
We don't, sometimes, you most don't, I find the periodic one more useful because you don't change the pipeline as frequently as your normal code. So the periodic one will catch things that happen outside. Yeah. So
that makes sense. Thank you so much.
Okay. If nobody has any more questions, we
Just the last one.
Oh, sure. No,
yeah.
Go ahead. I just didn't see it.
Does it make sense for you to actually have a stage for test after each stage in the pipeline, or you normally embed the basic tests within the stage itself?
That,
Like,
wha-
do
that
you?
you mean like in the normal pipeline, like
Correct.
test and then test both in the same
Yeah,
pipeline?
Does it sound too? I don't know.
It might be
frustrating?
an overhead in your pipeline itself because you don't if you're not changing these frequently, you don't need to be testing them every time if they're the same. So that's the only consideration. But you can try to do that. I think it's fine, but just that it might be an overhead in the pipeline itself if you're always running the same stuff when nothing changed.
I see. So then I guess the focus is more on what is volatile, right? What is constantly changing. Okay.
Yeah.
Thanks.
Okay, I think that's it. Thank you.